Did you know your overall health depends on a microscopic layer most people have never heard of? The glycocalyx? Welcome to the future of vascular health. Healthy Vessels, Healthy Future, the podcast dedicated to uncovering the hidden science behind vibrant health, longevity, and vitality. Brought to you by the Glycocalyx Research Institute, each episode delivers cutting-edge insights into microvascular health, empowering you to finally understand why you might be experiencing fatigue, brain fog, or poor circulation, even when your labs seem normal. Through actionable advice and expert interviews, you'll learn how protecting your glycocalyx can significantly improve circulation, support your heart, enhance brain function, and prevent serious vascular issues before they begin. Tune in weekly and discover how healthy vessels today create a healthier, brighter future tomorrow.
Hello, everybody, and welcome to The Better Life with Dr. Pinkston. I am Dr. Marianne Pinkston, and recording today with, we've had here we go, it's Monday morning. I have Robert Long on today, who has been on before talking about the glycocalyx, which we will explain in just a moment, and its involvement in heart disease. And we are joined today with Dr. Hans Vink, a PhD, who is very well-versed in glycocalyx as well, a graduate of University of Amsterdam and more. He's got a very lengthy CV, extensive research in glycocalyx and heart disease. And in the Netherlands, he's got more than 100 scientific publications. But what's really impressive is he has 10 PhD projects. And so if you know how hard that is, then it's incredibly impressive. And then Robert Long, again, is an extraordinary business executive and innovator in medical research himself, with 145 peer-reviewed papers and publications together. They have researched and developed the glycocalyx research, and developed a company called Glycocheck. And that is as brief as I can get and as well as I can do, gentlemen. Thank you for your history and longevity here. Welcome in.
Well, good morning. Good
Bob,
morning. We're happy to be with you today.
Thank you. Bob, we wanted you to explain a little bit about glycocalyx to get us started and kind of what's involved.
Right. So I was on your show back in May and went through a little bit about the glycocalyx. So today what we'd like to do is just reacquaint your audience with the glycocalyx, explain what it is.
Please.
It's probably the most important thing in their body that they've never heard of. So we've got some slides we want to share that we'll talk to. So your audience that's here with us on YouTube, I will be able to see those, but we'll give a good explanation to those that are just listening in.
Exactly.
So as you mentioned, Dr. Vink and I started working together about 15 years ago. And I joined Hans about 20 years into his journey. He's the scientist that, with his research group in the Netherlands, actually proved to the world that there is a glycocalyx. So we want to talk about that and explain what it is. And then together, we published a lot of research. We put our systems in academic research hospitals all over the world. And so today, what we want to focus on is the link to glycocalyx and your microcirculation, or meaning your capillary network, and how it's implicated in high blood pressure. And then also help you understand that. And then more importantly, we'll talk about what can you do about it.
Absolutely.
So with that, I'm going to turn it over to Hans.
Welcome, Hans. It's nice to have you on this morning.
Well, good morning. It's nice to be here, and thanks for having us.
Thanks.
What I would like to do, if I can share some of my slides with you, recap a little bit what Bob maybe presented a few months ago already on the microcirculation. What is microcirculation? What is glycocalyx?
Yes.
Why do we think it's important to know about glycocalyx in understanding hypertension?
Thank you.
And then also talk about our therapeutic Revasca that we've developed to repair glycocalyx and repair your microcirculation, and hopefully also help people to control their blood pressure better than they are able to do right now. So with that, I would like to show the next slide. And this slide shows on the left-hand side, the typical picture of the cardiovascular system that people know of. You have a heart that pumps blood into your large arteries. So those are the large red vessels,
Yes.
taking the blood to your organs, your kidney, to your lungs, to your muscles, to your brain, to your heart, and then it leaves the organs again in the big veins and goes back to the heart. Well, what many people do not know is that the real action really takes place when the blood enters those organs. Then the large vessels branch off in smaller vessels, and the smaller vessels, if you take a microscope, you'll get an image that is shown on the right-hand side. So 99% of all the contact area between the blood and the tissues, all where the nutrients are exchanged, the oxygen is delivered, is in tiny, tiny blood vessels called microvessels. So they're so small you need a microscope to see them. And at the smallest level, we call them capillaries. So those are microscopic capillaries. So when I started looking into these small blood vessels, I started using big microscopes to look in detail how blood is flowing through these tiny blood vessels. And then I got images like this. This is a live video of one individual microscopic capillary.
Wow.
And it shows in the center, these black dots are individual red blood cells flowing one by one through these tiny capillaries. So these vessels are so small that an individual red blood cell doesn't really fit. They have to be deformed and squeezed into one of the microscopic capillaries. And to our surprise, when we started looking in more detail, if you look at this vessel, you see the black lines on the side, which is the wall of that capillary microvessel. And those red blood cells are not touching the wall. There's a big gap where the red cells are flowing. And it turns out that gap is not just filled with fluid, it's filled with a very important transparent compartment called glycocalyx, like a gel that sits on the inside of your vessels, and it keeps your vessels healthy and prevents damage and prevents all kinds of cardiovascular consequences down the road.
And Dr. Vink, I don't want to interrupt, and I will, though. For those of you who cannot, are listening on iTunes, Spotify, or other media without a visual aid, if you go to the website, you can get the YouTube link and go look at this. This is phenomenal, and I want people to know they can access it easily if they run to our YouTube link on drpbetterlife.com. So please continue.
Yeah, no problem. I just, like you, I want people to understand the significance of this, that blood vessels are not just hollow tubes, and blood is not touching the wall of blood vessels. There's this very thick protective gel lining, like a non-stick coating, that keeps your vessels healthy and prevents all kinds of issues like hypertension.
Amazing.
So if people can see these slides, if you zoom in on that space where the red cells are flowing and the surface of the wall, then we get these kinds of images. This is a high magnification electron micrograph, an electron microscopic device, looking in more detail how that looks like, that space between the vessel wall and where the blood is flowing. So on the left-hand side is a cross-section of one of those capillaries in heart muscle. On the right-hand side is the same capillary with a higher magnification. So on top would be where the red cells are flowing. Below is the wall, and you got all these three-dimensional bush-like structures growing on the surface of your blood vessel. The blood vessel produces these bushes themselves, and these structures are made of what we call polysaccharides, those heparin-like molecules, and more specifically, they're called heparin sulfate, proteoglycans, and hyaluronic acid. And these structures are extensive. You can see that these bush-like structures are several times thicker than the whole wall thickness of the microcapillaries themselves.
Yes.
So this is glycocalyx. So these polysaccharides form a gel. They bind proteins. The proteins soak in fluid, and that prevents cells, red blood cells, blood platelets, and immune cells from sticking to the wall. And just to give people some context, what it means when that glycocalyx gel gets damaged. I show one or two examples. This is one example, again, at the capillary level. So on the left would be a healthy capillary with bush-like glycocalyx on the surface. On the right-hand side is a damaged capillary. You see the bush-like structures are gone.
Yes, very smooth.
They're very smooth, but we don't like smooth.
Right.
Because now the wall becomes very sticky. Red blood cells start sticking to the wall. And also you see on the outside, there's all this white space now. And that white space is actually fluid that leaks out of the vessels into the tissue and proteins. So on the outside of the vessels, a lot of fluids start accumulating. And this is the muscle cells at a distance again. And all this fluid, what you call edema, pericapillary edema, compresses the microvessels. So they become sticky, they become compressed, they become smaller, and as a result, you start losing a lot of those blood vessels. On the right-hand side, you start at 100%, like in acute setting, when you start having damage because of inflammation, for instance, you lose about 40 or 50% of those tiny microvessels.
Wow.
I'll come back to that a little bit later because that's also important for hypertension. If you lose a lot of your microvessels in your organs,
Yeah.
it becomes very difficult for the blood to flow through those organs, and that contributes to hypertension, for instance.
Wow.
And one other example is shown here. This is another important function of the vessels is to produce a molecule called nitric oxide. And nitric oxide is super important for blood flow control, dilating blood vessels, and preventing hypertension. And it turns out that glycocalyx structure on the surface of the wall is super important to tell the vessels to produce nitric oxide. It's a sensor. If blood flows too fast, it tells the vessel, well, we need more nitric oxide. Please dilate your blood vessels.
Open them up. Yes. Wow.
So that's happening. So on the top, with the thick glycocalyx, if blood flow goes up from left to right, the open circles show there's more nitric oxide being produced. And that prevents hypertension, for instance. When glycocalyx is damaged, and we know now glycocalyx gets damaged with all kinds of risk factors that we know of: smoking, lack of exercise, poor diet, aging, genetic predisposition, and more risk factors that we don't even know, or high glucose, diabetes.
Right.
The glycocalyx is damaged, then blood flow goes up. There's no trigger to tell the blood vessels to produce more nitric oxide. So there's a lack of nitric oxide production. And just this slide here just summarizes the consequences of a healthy or damaged glycocalyx. So on the left-hand side, the blue structures are those polysaccharides of glycocalyx on the vessel wall. So if you have a healthy glycocalyx, then blood flow increases. There's more nitric oxide production. There's also binding of antioxidant enzymes that keep your vessels healthy. And then the tight nature of these polysaccharides prevent leakage of fluids and proteins, but also prevents leakage of cholesterol, for instance. And then same for red blood cells that don't touch the wall, that don't stick. Also, healthy glycocalyx prevents blood platelets for coagulation and leukocytes for the immune response to stick to the wall. So a healthy glycocalyx is key in keeping your blood vessels healthy and don't get blood clots or don't get inflammation or don't start leaking cholesterol in your vessel wall, causing atherosclerosis, for instance.
Wow.
And on the right side, you see all the things that go wrong when glycocalyx is compromised. Because of smoking or because of your diabetes or aging, you start leaking fluids, you have lack of nitric oxide production, blood clots start forming, local inflammation because the immune cells start sticking to the wall. So that triggers a lot of diseases and consequences, and one of them could be hypertension. So that's just summarizing probably what Bob already shared with you a couple of months ago.
Yes.
And then, doing all the scientific research in academia, at some point we realized, this is a real thing. We need to take it to the real world, get people availability to test how healthy vasculature is.
Because it is treatable. I mean, that sounds all very overwhelming, I think, probably.
It is. Exactly. That's where I was like 15 years ago.
Yes.
I was doing all the science, showing that people's microvasculature was compromised. And then, of course, they want to know, what can we do about it?
Yes.
And that's when Bob Long entered my life. He gave me a call. He was interested. I was suspiciously interested.
Sure.
I didn't know. He started working already on the therapeutic. So on the left, we have our device with the camera to measure in individuals the health of their microvasculature and glycocalyx. And we call this device the GlycoCheck device.
Are you feeling tired, foggy, or noticing poor circulation despite doing everything right? The answer might be hidden in your microvascular health. Introducing Revasca and Renew, two groundbreaking supplements scientifically designed to restore and protect your vascular foundation. Revasca revitalizes your circulation, supports heart health, and naturally boosts your energy by repairing your blood vessel lining, the glycocalyx. Renew complements this by providing deep cellular repair, resilience against stress, toxins, and inflammation, and enhancing your overall vitality. Together, Revasca and Renew offer the complete solution for lasting health from the inside out. Visit glycocalyx.com today to learn more about how these powerful supplements can help you reclaim vibrant health and lasting energy.
And on the right-hand side, we have our third generation of therapeutic based on natural foods, seaweeds, most of them predominantly, that are very similar to those glycocalyx bushes, to repair and improve the health of your microvasculature. And hopefully all the consequences of the breakdown are reversible.
Yes.
And that's what we have been working on the last 10 years, to develop more supplement, make it available to people, and help them improve the health of their lives.
Wonderful.
And, with this introduction, I'm gonna show this slide. I'm gonna give the word back shortly to Bob.
Very good.
Yeah, so thanks, Hans. Before you get into explaining more about hypertension or high blood pressure, as your audience probably would call it, I just wanted to let you know that we had a special offer for your audience, because I suspect they may want to try Revasca. And
Yes.
so we have a buy one, get one free special offer. For those that are watching via YouTube, there's a QR code they can scan that'll take them right to our website. Otherwise, they can just go to glycocalyx.com. And if they go to the cart to check out, and they select 2 bottles, put in the coupon code BOGO, then they'll get 2 bottles for the price of 1. So they can try it out and see how it affects their blood pressure. So with
That's
that,
wonderful.
you, Hans.
Yes, and thank you for sharing that. I want people to know too, we're going to have that on the website so that you can take advantage of that and bring that I love bringing that at the beginning of the show instead of the end, so that people know there is a treatment, there is something we can do about it. You guys have it and are offering it at a great price that people are accessible. So that is wonderful. Thank you, gentlemen, for doing that. Go right
All
ahead.
right, well, I'll continue. If you don't mind, before I start talking about our studies, a little bit of basic background of what we know and understand about high blood pressure and blood pressure control. So this is a very simple schematic that shows our cardiovascular system as being a heart with large blood vessels taking blood to organs. Then we have in the organs what we call a systemic vascular resistance. So it's difficult for blood to flow through these organs because there's some resistance, because there's tiny blood vessels that have to flow through.
Yes.
Then blood pressure, or mean arterial pressure, which is your blood pressure, is can be simply calculated by having your cardiac output, how much blood the heart pumps into your large vessels, so liters per minute, multiplied by your systemic vascular resistance. So if you have a high organ resistance, and organ resistance can be high because you have stiff large vessels, or you lose a lot of your capillaries, or you have lack of nitric oxide production, for instance, because of lack of glycocalyx. All those factors can increase that organ resistance, the systemic vascular resistance, and at the same level of heart function, same cardiac output, same heart rate, that would actually give an increase in your blood pressure. So all these factors can increase blood pressure. So just as a reminder, I'll circle back to that a little bit later, more specifically. If you look at blood pressure,
It's interesting, Hans.
Sure.
When I first met you, not only were you a researcher, but you also taught physiology at the medical school at the University of Maastricht, and specifically, you taught a lot of the students that were at the end of their residency. And I remember you telling me that when it came to the topic of blood pressure, it was very difficult, and most people couldn't really tell a patient what caused it.
Right.
Yeah, that's true. That's one of the frustrating factors.
Right.
You start talking about blood pressure, high blood pressure. It's only very few percent it's clear what causes it. Most people there's no idea, and a lot of people don't respond to conventional treatment of hypertension or high blood pressure.
Yes.
So we need some new information to see how we can deal with that and how we can improve it.
And on that note, you brought a good point that a lot of physicians, very well trained, finish medical school at the end of their residency, unable to explain some of these, very important factors that are important for doctors to take forward and treat patients. We were not taught. Many different areas that occurs, not just with the blood pressure, but in the cardiovascular system, nutrition, et cetera. We just are not taught the basics here. This is very important.
No. So there's a lot of information that people are not aware of.
Right.
So that's why I take this opportunity to share a little bit of the background and basics. And our blood pressure, can blood pressure be too low, or what is too high, and why is it important to know? And just as a little bit more information, if this on the left-hand side is a schematic of our cardiovascular system. So you have the heart pumping the blood in the large arteries like the aorta. Mm-hmm. Then those aorta branches off in arteries that go to specific organs. Then the blood flow through small arterioles that control perfusion of the organs. Then you have your capillaries where all the nutrients are being exchanged and delivered to the tissue cells. Waste products like CO2 and lactate and that sort of stuff is collected in the blood and transported back via the small venules and veins back to the heart. Now, on the right-hand side, it shows what happened with blood pressure. So the red bars are blood pressure throughout the cardiovascular system. So on the left, again, we start in the aorta. So when the blood just leaves the heart into the large artery, let's say you have a mean blood pressure of about 100. Then when it hits those arteries that branch off of the aorta to a specific organ, so those arteries are still pretty big in diameter. And the blood pressure doesn't really change much because there's not a lot of resistance in those large tubes. But as soon as they get down into the smaller vessels and the small arteries called arterioles, those are the high resistance blood vessels where actually blood flow is controlled to a specific organ. So when you open those or close those, you can actually increase or reduce the blood flow to a specific organ. Those have high resistance. Oh, excuse me for that.
Sorry.
And that's actually where the blood pressure drops most because that's where the highest resistance is. And then the blood enters the capillaries where all the exchange takes place, and then it enters back to the heart. But that's where already the blood pressure has dropped significantly. Mm. But that part is actually where all the blood flow is controlled, and the diameter, the tightness of these small arterioles, and it's also controlled by nitric oxide again, for instance. That's where blood flow to organs is controlled, but also controlling that organ resistance and the systemic resistance that's so important for blood pressure control.
Yes.
Well, another question is, how low can you go? We know high blood pressure is bad. So it doesn't mean the lower, the healthier, or is there a minimal blood pressure that you need below which you get other problems? And that's actually shown here this is an example on blood flow in the kidney. And actually focus on the middle panel where it shows renal blood flow. So that's the amount of blood flowing through your kidney every minute. And the kidney needs a minimal level of blood flow to give nutrients and oxygen for kidney function. And actually the kidneys, those small arterioles inside the kidney can actually control blood flow to keep blood flow constant in the kidney at a constant level of need for oxygen. Mm. The horizontal axis is actually the blood pressure in the large vessels supplying blood to the kidney. So similar to the pressure in the aorta, because it doesn't drop really when it goes into the renal artery. But this shows that as long as blood pressure is higher, like 65 or 70, on the middle panel, you see the blood flow stays super constant. Mm-hmm. Actually, that's called autoregulation. The kidney itself doesn't really care what the blood pressure is on the entrance of the kidney. As long as it's higher than 65 millimeters of mercury, then the kidney arterioles constrict or dilate, just accommodate what the kidney needs for blood perfusion. Keeps very constant. So, but there's a minimum. So when blood pressure drops too low, like below 65, then all those arterioles are fully dilated. Organ resistance is at its minimal level, cannot be reduced any further. So when that happens, if blood pressure drops below 65, an average pressure of 65, then proportionally the blood flow through the kidney will also decrease. The kidney cannot accommodate anymore, and that's bad. But now you have too little blood flowing to the kidney, and the kidney will be damaged, and you have kidney failure. So there's a minimum. So you need to have a minimum blood pressure of 65 or higher to keep all your organs healthy.
That's the top number, correct? Right.
Well, that's the low number.
The low number, excuse me. Okay. All right.
So you need a little.
Teaching me something now.
If you are in the ICU, and for some reason you have low blood pressure, they try whatever they can to keep that blood pressure above 65. Because it's too low, then organs will be underperfused, will not get enough food and oxygen, then organs will be damaged, like the kidney or the brain. So that's a minimum, just to start with. Now, what about higher levels of blood pressure?
When it comes to blood pressure, then there's a high number and a low number, which you're going to explain right now. And so that's important on both ends, and that's what you'll talk about next.
Right.
Yeah, so when the heart contracts, it pumps every second or so. There's one beat of the heart. So it squeezes out blood into your large arteries. Then the heart relaxes and fills again for the next beat. And then if you look at blood pressure in those large arteries, as soon as the heart contracts, blood pressure will go up to its highest level, and that's called systolic blood pressure. So that's the high number that you get when you measure your blood pressure. That's in the middle column. And then the heart relaxes at the end of the heart cycle, just before the next beat. Blood pressure will drop a little bit, and that's called the diastolic blood pressure. And that's the low number if you measure blood pressure. And then, just for those people that would like to know, to calculate your mean blood pressure, your average blood pressure, that's the mean number that people need to know. They take 1 time the systolic pressure number and 2 times the diastolic pressure number, and then divide it by 3. And then you get your mean blood pressure.
Nice.
But anyway, so these numbers, you have a high number and a low number. So in a healthy, normal situation, like say what's assumed to be like an ideal blood pressure, would be about 120/80. And then when people's blood pressure start increasing, first they call it pre-hypertension, then hypertension stage 1, hypertension stage 2, or a hypertensive crisis. But that shows you that different stages, blood pressures go up from 120 to 140 to 160 to over 180, over 110 when people are really out of control.
Yes.
So why do we care? Because we know there's a minimal blood pressure. As long as it's above 65, organs get enough blood and they should be happy. So it should not matter too much whether it's higher than that, because they just get more blood flow and that would be good for the organ. Well, for some reason, it's associated with a lot of cardiovascular risk and complications.
Thanks for listening to The Future of Vascular Health. Healthy vessels, healthy future. Ready to uncover what's really going on beneath the surface of your health? Take our quick Revasca quiz today. Discover how well your Glycocalyx, the crucial microscopic lining of your blood vessels, is functioning. Revasca isn't just another supplement. It's a scientifically backed solution designed to naturally strengthen your vascular health from the inside out. Say goodbye to persistent fatigue, brain fog, and circulation issues. Say hello to lasting energy, clear thinking, and vibrant health. Go to www.revascaquiz.com now to take the Revasca quiz and start your journey toward better health today. Because protecting your Glycocalyx means protecting your future.